I don't know how to emote that. Easier to write than, so anyway, I hope you're here. I hope you can read. If you can't read, that's where here, and you can leave now. But you've outed yourself as illiterate. Anyway, so let's just get started here. First of all, my name is Joe Carlson. Those are my socials. Quick history about me. I was formerly a technical lead and engineering manager at Best Buy. May not know this, it's the third largest e-commerce site in North America right now, behind Amazon and Walmart. And then you've caught me at a weird time in my life. I am actually currently working at MongoDB as a software engineer and developer advocate, hence the MongoDB swag. So anyway, I would suggest following me on Twitter. That's my GitHub. I'm going to have some resources on here too, including links to a bunch of stuff on here. So I'll be posting slides, code, and a bunch of additional resources on my Twitter afterwards if you're interested in that too. I post a lot about technology ethics, front-end performance, JavaScript, Node, and I'll be posting about NoSQL a lot too here with my new role. So if you're into that, you should definitely check that out. Okay, cool. This is a good turnout. I love this room. It's a little more intimate. It's great. Okay, so I want to I like setting some ground rules before we get started. First thing I like to say is I'm personally don't like lecture style type talks. So I encourage you to ask questions if you have any. And some guidance for questions. Try not to ask something like, what about this feature? Like ask it about things we're currently working on, or if you want to elaborate on something. It doesn't throw off my flow. You can go ahead and ask it. We will be leaving time at the end for questions, and I will be available in the hallway afterward. I think we have lunch afterward. So anyone wants to talk about front-end performance or some stuff you guys are working on, I'd love to chit-chat about it. Otherwise, I'm always available online, so you can always hit me up there too. Other things too, this talk is being recorded, so if you don't feel comfortable with that, it's okay to leave, no worries. If you're asking questions though, just note that your questions will be recorded in perpetuity on the youtubes.com. Cool. Great. The other thing too, I'm going to be repeating the questions too after you've asked it for the microphone and for the online audience. Okay, I think that's the ground rules. So ask questions, I'll be around, whatever, and you're being recorded. Okay. Yeah. I don't know about you, whenever there's a camera on me, I'm like, I don't know. It's fine. Okay. Let's get started. Oh, one last thing I want to say too about this talk. It usually doesn't go a whole hour, which I think works fine for this because we're right before lunch, and usually people get ants in their pants really bad right before this too, so you probably get out a little bit early for lunch. So you're welcome. You're welcome, everyone. But let's just jump in. So this talk is about running JavaScript with multiple threads in the browser. So I want to talk a little bit about, first of all, what threading is and the history of it and why the design decision was made, and then also some of the benefits you're going to be getting from running multiple threads in the browser and why you should give a shit about this. So JavaScript originally was designed to run on single threads, and it's been pretty much the only way it's been able to run until fairly recently. So the question is, why? Why single threads? What are the benefits of using that? So let's see, first of all, before we talk about that, single threads. Can anyone here tell me what single thread means? Can someone, if I pretend I'm a 5-year-old child, I've never heard of this. What does a single thread mean? One what? One execution path. One execution path, yes, exactly. Has anyone ever heard of a quad-core computer or something like that? That means your computer has 4 cores, 4 CPUs, and that means you can run 4 threads concurrently with a quad-core, right? And there's other things too, they're doing multiplexing and stuff like that too, but we're going to keep it simple. But JavaScript, if you have 3,000 cores in a computer, hypothetically, JavaScript is not going to take advantage of any of those other cores. It's only going to be running on that single thread. Okay, cool. Can anyone here tell me some program languages that do utilize multiple cores? Go, yep. Go is famously doing that massively. C++ does, yep. Python, yep. Java. Pretty much every other server-side program language utilizes multiple cores except for Node. And that's actually one of the defining cool things about it. And we're going to talk about why that design decision was made. So Why single threads? First of all, easy to program. So has anyone dealt with who's done, I know it's a JavaScript conference, but with a multi-threaded programming language, with dealing with issues with data being sent through different cores at different times, race conditions being done, right? That sucks. If you deal with the single-threaded programming language, though, it's going to execute your code one line at a time, and it's much easier to predict how that's going to work. Easy use, much easier to program from a developer perspective. Easier to debug and test race conditions, and can be really hard to detect and judge. And if you're running multiple threads, it can be also hard to tell where that problem is actually happening. Porting code is extremely easy too. So let's say hypothetically I design a program that runs on a video card that has 100 threads on it. And then I want to port that code over to a Raspberry Pi with a single thread and no video card on it. Is that going to work? No, it's not. And that's because the hardware does not support code that runs multiple threads on it. However, single-threaded code works everywhere. If you have a CPU, you can port that code over to a huge multi-threaded computer. It's going to work, right? Or a small little processor. It will still work. I also put this one, faster than multi-threads, but there's a little asterisk on there. One of the key benefits of Node is that it's single-threaded, and which was pretty revolutionary when it came out in 2009. But it's not true for all things. So Node is really, really fast at dealing with really quick I/O, right? So like chat applications, really fast HTTP stuff where just data comes in and does maybe just a tiny bit of processing is sent before it sends a request back out again. However, since Node in JavaScript is single-threaded, that means that data-intensive processes, let's say maybe hypothetically I'm writing a tax calculation software and data comes into my Node server. I have to do some massive calculations. It maybe takes a couple seconds. That single thread is blocked, and all the requests coming to the server have to be queued up and to be handled later. Single-threaded frameworks and servers do not work well for those types of situations, but they're really, really good at handling really fast I/O and non-data intensive processes. And lastly, single-threaded, like JavaScript can do anything. Node in JavaScript can do anything. Like we could build that hypothetical tax software that has really data-intensive blocking operations on it, but it's just going to be slower in that instance. But theoretically, a single-threaded framework can do anything a multi-threaded programming language can do. Okay, cool. So JavaScript chose single-threaded, like a single-threaded design. Great, and there's a lot of great reasons why it did, and it made sense. But what's the problem? You know, hang on. I had a joke there. We're gonna skip it later. I blew it. So let's see here. The problem is though that the single thread is shared with the browser. So that means that the UI layer is shared with the data computing thread in the browser. Which I'm gonna go off on a little rant about some of the front-end frameworks in a little bit here today too, how they're choosing to do this, but we'll talk about this in a second. So what does that mean? It means that if you're doing data-intensive processes in the browser, that means that the browser is going to be totally stuck. It's not going to be able to do anything. So let's see here. Actually, can anyone tell me some stuff that that require a lot of CPU utilization in the browser? Transitions. Yeah, sure. What kind of CSS transitions? Yep. Oh, that's true. Yep. Yes, 3D rendering, which is getting more common in the browser. Absolutely. What about something we did a lot at Best Buy was parsing in massive data payloads from backend. And parsing massive data payloads can actually be pretty data intensive for the browser. Kind of touched on this too, image processing. Maybe you're doing some pre-processing in the browser before you send that to the server. Sound processing. I think there's a MIDI talk here too. That can be data intensive for the browser. Real-time analytics, and of course video processing too. Yeah, that stuff takes a long time for the browser. And if you're doing any of that, you're like doing that any of the server-side stuff, you're going to be that's going to cause some blocking operations. So let's see here. Okay, great. Oh man, Why did I do that? It like blocks it. Speaking of blocking, until it's done with the transition. Okay, great. So I'm actually going to demo this. What does that mean? So what I've done, this is the code I'm going to be running here in just a second. All it is a little index.html, and I'm running just a massive for loop. That's all I'm doing. It's got a, I don't even know what number that is. But what's going to happen is I'm going to click a button, the start loop, and it's going to run this intensive process. And this is a blocking operation in the browser. For loops are a blocking operation, which means it's going to block the main thread. And remember what we said, that the browser gets stuck during these massive calculations. So this is a simple example, right? But let's see how this works. Okay, let's see. You know what I'm going to do is, so my touch bar broke on my Mac last week, so I have to get a new one. So everything's like been reset. Yeah, I think I spilled water on it. Don't tell tech support that I did that, but which is really bad for presentations because that's where my escape key is. I couldn't escape out of it during the presentation. That was a nightmare. Okay, great. So code, the code I promised you. We have our start loop, and then I have the say hello. All it is an alert that pops up every time I click on it. I'm going to show you how running this massive for loop that blocks the main thread blocks all other UI operations in the browser. So we're going to start this loop. It's running, and I'm clicking say hello, and nothing's happening in the browser right now. The browser's completely locked until it's done with that for loop because the UI thread shared with the data computation thread in JavaScript and the browser. So if you're doing data-intensive process, and there, now we go. So we got this, and now because they get queued up on the stack, now we're going to see a bunch of the alerts running all at once. Right? Now it's done. The main thread's been unblocked. That's just a for loop running, right? And it's blocking. So is this a good experience for our customers or like people using your site? No, I don't want people using my site. They don't give a shit about my massive for loop happening in the background. They want to keep using the site. That's a problem. That's a problem. Okay, let's get back to it. So, my demo, great. Okay, so I'm running this on a 2018 or 19 MacBook Pro, and it's still taking a couple minutes to run this for loop. Can you imagine what that's taking on an iPhone or a Android device from 10 years ago? Like, that problem's going to get even worse. That's even slower. CPUs can't handle, like, aren't as fast. Actually, so when I first ran this talk, I was recording the talk from this machine. And if I uploaded the whole talk to YouTube, you can see it. The second I run this demo, the CPU gets totally clocked to my MacBook Pro, and it freezes the video processing thing for the rest of the video. Learned not to do that. Thanks. I'm glad we got an external recording here for this. It does not work with this presentation. Okay, so great. We've proven that CPU-intensive processes actually is a massive problem for customers in the browser. So how do we deal with it? I want to talk a little bit about how we used to deal with it, and then we'll start talking about, of course, where this talk is inevitably going, how to fix it with some modern tools for free in the browser. So, great. Old school, something we would do too, would send data-intensive processes to the server for external handling. So, like our example earlier, we have some video or image processing. Great. We could do that in the browser. It's going to block the main thread. Send the unprocessed image to the server, let them handle it, and let's receive it back. It's totally doable. People do that all the time today. Not a big deal. But you should be aware of the costs. So these are the numbers. These are the numbers that everyone or Google thinks all developers should know. If you haven't seen this list, I would suggest checking it out. It's a really important list, I think, for making design decisions with your applications. As you can see here, though, caches, and the closer your cache is to the main thread of the CPU, the faster the operation is going to complete. And as we start going down the list, we're getting further and further from the main CPU thread, and we're going onto hard disks. And then on the bottom there, we're actually doing a round trip from California to the Netherlands. So in this hypothetical example, we want to do some image processing. Is it going to be faster for us to handle that on the main thread in the browser, or is it going to be faster for us to send that from California to the Netherlands and back again for processing? It's going to be faster to just do it in the browser. So you can do the server, you can send it to a server for processing, but you have to be aware of the cost of what that's going to be. And if we can make use of like doing that in the browser and not having to make a round trip, that's going to be a better, faster experience for customers using your application. I'll tweet this out too, but this is probably a good one if you're a photo taker of talks, this is a good one to take a photo of. I should have like an emoji for when it's a good one. So great. That's how we used to do it, sending, and we still do it today. But all browsers now have a baked-in way of dealing with multiple threading in the browser. There's no third-party tools you need to use. You don't have to import anything. You get it for free. You can handle multiple threads in the browser via web workers. And a web worker essentially allows you to run a JavaScript script in a separate thread in the browser. That's all it's doing. And we're going to be jumping into that too. They're kind of weird. There's some weird gotchas in there. We're going to talk about some of the weird stuff about it, give some examples, and we're going to show you how to speed up that for loop that we wrote earlier. That's a big good one. Dang it, I didn't think of that. You're right. Yeah, that's right. Just make it 10 loops, easy. Okay, cool. So web workers, benefits, faster making round trips, more responsive, so we're no longer blocking that main execution thread so users can start clicking on stuff while we're executing stuff behind the scenes. Battery efficient. It can be faster to do it on your CPU. Not many people know this, but actually opening up an HTTP or like a connection, a mobile device or phone, actually is more data intensive. I was reading a case study from, I think it was Shazam, but they were one of the, like, this was like probably 7 years ago. They were one of the most like battery intensive programs running on iOS, and they had no idea why. And they did some research on it, and they found out that they were sending analytics. They were pinging an analytics service. They were just opening up a connection and sending over like a little analytics data packet like every minute or something like that. And opening that up for that tiny little data packet was just destroying the battery life of the devices that was working on. So they started batching those requests up and improved battery life of Shazam massively. Cool. Oh, and lastly too, this is a big question I get. Support, what does that look like? Support in all major browsers, including IE 10+. It's been out since IE 10. That's one of the most messed up things about this, and something I didn't even know until I started working on this, is like this has been out for a long ass time, and like most companies are supporting 10+. I don't know. Is anyone supporting lower IE versions right now? We didn't at Best Buy. I don't know. Right, it's supported, right? So, I'm going to do a pause here. How are we doing so far? Any questions so far? Yes. What about? Oh, like support? Yeah. You can. Yes. So it depends. Of course, like we talked about earlier, multiple threads doesn't work on devices that don't have multiple CPUs. So you could potentially be on a phone or device that is single-threaded or running on a Raspberry. Raspberry Pi is multiple-threaded? I don't even. Maybe they are. I don't know. The new one? They are. Okay, cool. Maybe I gotta find a different example for that then. But like, sure, hypothetical single-core computer. I will be talking. Best case, I'm going to show you two best practices for this. You should still be doing a check to see if the browser supports it, and there's ways to do that, which I'll show you here today too. And then the fallback is to just do it single-threaded, normal style. So we'll show how that works. Okay. So I'm going to show you some gotchas. We're going to dig into some real code. My philosophy on code with kind of presentations like this, I have an hour. Code doesn't stick with people. It's like, I don't know, like cotton candy or something. You're not going to remember code later on. I'm going to show you what it looks like, so I think that's important. But I don't expect you to grok web workers today. I expect you to grok it if you go home and start playing with it and start using it. So this is just kind of introduction to it too, but I will show you some examples. But let's continue. Web workers can directly access the window object. So that means what happens is when you start executing in a separate thread, it makes a copy of it, and these single threads are similar to the main execution thread that you're used to working in, but you're lacking some key things that you might expect. And the two big things are you cannot directly access the window, and you cannot access the DOM via the thread. You have access to everything else. You can make use of array methods. You can make through object, like all the other JavaScript functions there. The only two things you can't do are deal with the window object and the DOM. That means what you're doing then is all the other threads are the data-intensive processes, and your main thread is completely reserved for UI updates. which I'll make a note here. Every other programming language in the world does this except for JavaScript. And I have no idea why the fuck most React, Vue, and Angular are doing all their UI execution and data-intensive stuff on the main UI thread that blocks. I have no idea why they're not utilizing web workers. I have no idea. Everything else reserves the main thread for UI updates for a better customer experience, except for JavaScript and except for the big framework designers say. I do not understand why. That means web workers are designed for data-intensive processes. And your main thread's reserved for UI updates. Okay, great. So how do they work? Let's get in some real code here. Take a peek at it. Instantiating a brand new web worker in your browser is actually pretty easy. All you do is just do a new worker, and then you link to the file. Whatever's in that JavaScript file gets executed on a brand new thread. I read ahead there. I think I wrote this slide. Okay, let's do a little demo here. I'm going to show you another project I love. So I didn't write this. I'm stealing this from somebody else. I'll be putting a link in here as well. It's a MD5 password cracker. It's a brute force password cracker in the browser. I would not recommend, this is not an efficient one. If you want to write a really efficient one, I'd write it in something that isn't a browser. This is purely for demonstration purposes. But what's happening is each worker here is brute force passwords, or brute forcing passwords to figure out what the real password is. And you may not know this, but in Chrome, let's see, and then is this large enough? Can people see what's happening over here? Can I make this bigger? Is that good? People in the back? Just give me a nod. Cool, yep. In Chrome, you can actually, it shows you threads now. So we have the main thread running here, cool. I'm gonna refresh the page. Keep an eye on the number of threads that are being instantiated on this page. Boom, all these workers are being instantiated as a separate thread in the browser. And what happens is each of these is separately finding a password, and once it's found by one of them, it cancels all the threads once it's done. Once it finds it, closes all the threads, ends it. We'll do that one more time. All the threads start spinning on a computer, trying to guess that password. Boom, it's found, shuts it down. Cool. All right, so let's take a look at what that might look like. I always keep a GIF version of this in case internet doesn't work or something, but it does. So I'm just going to skip this for now. So we talked about that main thread. So the main thread is reserved for UI updates, and we have all these workers. So for example, that password cracker, each of them is going out independently to go find that password, but we need to make sure we're updating that main thread when we found that password, and we do that via messages. And this is an example. It's basically a callback function. It's an event listener with a callback function. So the workers are firing off events to the main thread, and when those messages get received, we have some sort of callback function that runs, and we can do something with that. The two biggies that we're going to be working with are on message and on error. Always want to do our error handling, do something with it, great, and messages. So we can talk about that too. Already talked about that. Already talked about that. Can do everything the main thread can do. All right, let's look at some real code. Like I said, I have all this code in my GitHub. I will be posting some on Twitter afterward, so feel free to check that out. But let's just take a peek at it. This may be you at first, but I promise we'll get through it too, and we can totally chat about it. So, great. You know what? I'm just going to jump into the real code. Okay, so this is our slow example. Great. Let's look at our fast example. We're going to just jump all the way in. We'll go one at a time. Ignore some of this other stuff here too. This is our error handling stuff. What I want to do is focus right now on the on message. So this is handling the main thread from that browser. A common pattern I've seen with handling messages, because we have one message handler, but we may have multiple messages coming back from our other threads. So for this example, this is my big loop. This is my fancy big loop. I have a status, I have a completed, and then I have a, if anything else happens, just kill kill the thread, something wrong that we didn't handle is there, so murder it. But status would be like when it's not completed yet, and then once it's complete, what I'm doing is updating the DOM with that data from that separate thread. Okay, so again, we're instantiating a brand new thread called big loop. Let's go take a look at our big loop code here, and here we go. This is just our thing here. We just have a for loop running some sort of thing. Every 5,000 iterations, I'm sending a status update to my main thread, so we can kind of keep track of that from the main thread. And then once it's all done, I send that complete data back to our main thread. All right, let's take a look at that. I don't think I've actually shown you how that works yet. So where's that? There we go. Okay, so again, keep a track on this call. Is that the, no, where's the, sources, I think. Is that it? Is that where it's at? Yeah, where's the thread? Oh, who knows? We'll find it. I think it'll pop up here. So same thing. We have the alerts on here, just like we had before. But we have a start worker, and that's going to be starting our big loop on a separate thread in the browser. So we should keep a look on the threads over here. And then we should also be aware, I'm going to be clicking on this button here to show that the UI main thread is still unlocked. So, yep, there we go, thread. That finished up really fast, completed. Let's try that again. See big loop starting. I'm going to make that a little bit bigger. So it takes longer for us to go. Big loop's still going, currently on there. And hello, still going, even though, and it's completed. That main UI thread is unblocked by handling. And you can see that worker is being handled in a separate thread in the background there. And it's done. Okay. So let's see here. Any questions about the on message? We're going to be getting to polyfilling, error handling, and some other weird stuff in there too. But any questions just about the on message part so far? Cool. Pretty straightforward, right? It's just like we send over some data intensive stuff, and we just send over a message to the main thread with whatever updates we want to make to it, and we handle that. Not too bad. Good question. We'll be talking about that at the end too. Yes, good question. Yes. So when should you? We'll be talking about. The question was when do you and when do you not use web workers? And we'll be talking about that very quickly.
So in this case, you only had one web worker.
Yes. Yep.
Which is why there's only one message.
Exactly. Yep. Exactly. Yep. But we can spin up as many as we want. We could also do something like, if we want to do multiple, we could just do. Whoops. And all my Visual Studio Code stuff got web worker 2, and let's see, where did I do that? And web worker 2. So we could spin up as many web workers as we want. Let's actually try this right now. Oh, so now we have 2 threads running in the browser.
If you weren't receiving messages from that side.
No, I'm not handling that because I'd have to do like. Right now this is on worker 1, but I have to do like a worker 2 on message or something for that.
So you're getting a new worker so there is a worker. So if we click start worker and it creates a new thread, if I again click the start worker,
yep.
Will it again create like 4 threads now?
Ooh, good question. Let's try it. No. Oh, I see. Okay, I can show you why. So the reason why is because I've actually instantiated these variables outside of the function scope, so that in the global context, there's going to be 2. And if I click it again, it's going to just overwrite the original 2 and start them over again.
Oh, it's going to overwrite, so it won't be a different worker.
It won't be. Yeah, exactly. Like basically restart it in the same namespace. Yeah. But you could, if you move these inside, that probably would work that way. Just the way I've written this code, it is impossible to. Yeah, another question.
So how would you pass data to these workers?
Good question. Yes, we'll be getting to that too. Yes, absolutely. Because you can send data back and forth too. Oh, question. Yeah, the question was how do you? I always forget this. The question was how do you send data to the web worker? And we'll be talking about that in just a second. Good question. All right. Stopping web workers. I'm going to talk about that real briefly here too. If you need to shut something down, there's ways to do that. Let's get to it. So it's really easy. This is actually the stop worker function I'm using. But there's a terminate function that just ends it. And then what I'm doing is I'm reassigning worker to be undefined, so it kind of frees up the namespace to be pulled up again, so we can kind of reallocate it. You don't need to do it, but I'm doing it in this instance. Pretty straightforward. I'm just going to move on from there. Great. I think this is me showing that it stops. I think it took me like a second time then it terminates it before it completes. Okay. Errors. Sometimes an error gets thrown. We need to handle it. I already showed it too, so I'm not going to. We have a worker message event that handles, fires up something. Right. I'm going to skip it though. Pretty straightforward. Okay. We'll talk about browser support, and we'll talk about some more advanced use cases, including importing separate libraries and passing data back through it too. So some browsers, like we talked about before, if the hardware doesn't support multi-threads, or it's an old browser that has no web worker support for it, we need to make sure that we're handling that correctly. So this is kind of weird, but we'll walk through it really fast here. Man, I don't have a mouse in this mode. The first line, though, all we're doing is checking to see if capital W, the class worker, exists in the browser. And if the worker class is defined by the browser, that means the browser supports it. So great. So we're just checking, is that there? We're checking if that worker is been utilized or not. Remember how I reassigned worker to undefined when we terminated that worker? We're checking to see if that worker has already been used up or not, and we do that by checking to see if it's been assigned to another worker in there. And then if it isn't, we assign a brand new worker thread. Else, yeah, otherwise we're handling. Either you can just do a single thread, you can just run big JS without a worker, like on the else statement down there, or just error out. Depends. Yeah, maybe, for example, like maybe we're doing image processing in the browser. Maybe we have a fallback option just to send that to our server HQ for image handling processes or whatever, right? We can have some sort of backups. Okay, let's see here. I actually don't have a slide for this, but I think I'm going to show it. A big question I usually get too. Let's say I have underscore JS or something I want to utilize in a worker thread. We don't have access to the window or DOM object, which means if you import a library in the page, you do not have access to that library on the worker thread. You have to separately or independently import all the libraries you want to use in each thread. Kind of annoying, but you can do that with this import scripts command. You can import as many libraries, tools, whatever you need to utilize in there. And yeah, you wouldn't be importing something like React, because React is a UI framework, and you do not have access to the window DOM object, and you don't want to be doing UI updates or processing in a worker thread.
How does that work with things like Webpack?
Good question. I do not know. I bet I haven't done this personally, but I would be willing to bet large amounts of money that there's a Webpack plugin you could probably get for making sure that this stuff gets imported correctly, or something. I don't know. Yeah, I haven't looked, but that's a great question. Could someone do a Google for me? I'm going to crowdsource this a little bit. Can anyone see if there's a Webpack plugin for importing scripts into web workers?
There's a Webpack loader.
Cool. Awesome. Yep. Great. This is great. You guys are doing the work for me. This is awesome. I should say I'm like not an expert at this. I'm just like a guy who like wanted to learn this. I learned this about 6 months ago and kind of wanted to figure out too, and how to share some of the stuff in there too. I do utilize this stuff, but we'll talk about that in a second. And let's see here. Also, let's see, I don't have the example on here too, so I can't remember. Can someone else, I'm going to crowdsource this too. Can someone look up for me how to pass over data to a web worker from the main UI thread for me? Okay, answer. Is it post message from the main thread? So you can do like a, I could do like a, I don't know, post message, like worker.post message or something. Cool. And that'll send that back. And I assume it's an event that gets like on data. You can handle that in the main thread or the worker threads or whatever too. Thank you. All right, cool. Great questions so far. Future, okay, let's talk a little bit about the future. So web workers have been weird for me. Like, they've been around for forever. All browsers support them. I think they can do a lot of good in the browser. And as we all know, we're putting more and more data-intensive processes in the browser. I think some people brought up some shaders, 3D processing, web worker, or like, let's see, I think I have an example here. I thought this looked like a future 16 Piklebowski. I don't know. Anyway, yeah, WebGL and Canvas 2D. So a lot of them are games and 3D engines are in there. You may have seen some of, whoops, dang it. PowerPoint's hard. This is an example of a Google Chrome experiment using WebGL and doing some pretty intensive 3D modeling in the browser. Personally, I do not think this trend is gonna keep getting. We're gonna keep seeing more and more work being done by the browsers. I don't think like handling data-intensive processes is just gonna keep exploding. I personally think that web workers need to be utilized more. I brought this up earlier. A lot of all front-end frameworks I'm aware of, all the major players right now are not utilizing worker threads and are doing all the, like, for example, React. React is doing all the virtual DOM diffing. The Fiber engine works completely on the main UI thread. If it's doing a heavy diff processing, that's going to block UI operations. Why the fuck are they not doing that on a separate thread? I don't know. I would be willing to bet we're going to see more of this in the future. And as we start building more intense data, like processes in the browser and application on the web get more and more intense, I could see this being a great tool. The thing I love most about web workers is it's not a tool or framework. This is like, it's core to the browser, and it's going to continue being core to the browser. It's free. You don't have to import a new library to get this to work. You get it for free. Okay, let's see here. I can't remember if I talked about this in here. I want to talk about when to not use it. Yeah, okay, here we go. Yes, good. So when do you use them and when do you not use them? So let's look at our code here again. This is my code for a web worker for loop, and this is my code for a non-web worker for loop. Which one seems more complicated? The web worker, yeah. Web workers you're adding a lot of code overhead to your application by using web workers. Like we stated right away, the benefit of using a single-threaded programming framework is that it's easy to program, easy to debug, easy to test. If you start introducing threads to your application, you're introducing a lot of complexity to the application. You want to make sure that that the performance cuts you're hitting are worth the application and cognitive load you're adding to your development team by adding those threads to the browser. For this for loop example, I'd probably just lower the for loop, try to find a different way to do this before adding a web worker to this application. So it does not work for everything, or it doesn't work for all applications, and I wouldn't recommend it too for like things like don't use it for like XHR requests or AJAX or whatever you call them, right? Those aren't blocking on the main thread. I think some people don't know what is a blocking operation versus what is. So make sure that you're not utilizing these things for operations that are blocking. My personal best practice for anything performance related is don't touch it unless you need it. So if you're building an application, build it single threaded until you start seeing some performance hits with it, and then maybe start considering refactoring it. What's the saying? It's premature optimization is the root of all evil. I think that's true all the time. I would wait till you need it, then I would start pursuing web workers as a possible solution. Of course, if you want to mess around with it in your free time, go for it. But if your customers are complaining about stuff being blocked in the browsers, this is a tool in your tool belt that you can use when you think it's appropriate, right? Adding just a new screwdriver to your web worker toolkit or tool belt and making better applications for people using our sites. Okay. Yes, web workers are great. Okay. Cool. Questions? Yes.
So with like the
Yeah.
They use 5 threads if I remember correctly.
I think it's 8, but yeah, same diff. Yeah.
So, like, what happens if the
Or 7.
machine's running on doesn't have 8 threads available? Like, what happens if you surpass the maximum?
Ooh, good question. So they are supported, but it won't. Good question. Oh, the question was, what happens if you're running in a browser that has, for running 8 threads on here, but a computer only has 4 threads? Good question. I don't know. I'm assuming what will happen is they'll queue up on the stack, or on the stack to see it, like, and then they'll have to wait for their turn, just like it would a single thread. So if this wasn't running in a single thread, it would still run this like 8 times, but each one would be blocked by the one before it.
So kind of like your single thread with the pop-up message.
Yeah, exactly. So it may still be slower. Well, I think it wouldn't. If you design your application so all the data-intensive processes were like off, that main UI thread still probably would be safe. It just may take longer for the computer to actually do that processing in the background. But I think it would still be unblocked.
Yeah, I imagine it would work a lot like if you have multiple programs running on your application.
Yes.
You're going to have way more threads than you have cores.
Yes.
OS manages that and swaps them.
Just queues them up. Yep, exactly. Swaps them out. It's just slower.
But something like stop message probably wouldn't work in the same way.
It might, and I don't know exactly how the browser handles. So the question was, how does stop message work if that potential queuing up of work or happened? I think it still would, because, well, maybe that stop. If you click that button, hopefully the main thread would be unblocked, and it could still fire that off to the separate threads. So I think it should still be okay. Depends how free that main thread is, but it may take a second. But any other questions so far?
I think it'd be more beneficial if you use the function as service rather than doing this.
Function as a service, like it's talking like a service model.
Yeah.
So the serverless, you're still making a round trip. So you're making a API request to some server somewhere and getting that data back. So you're paying. The one thing we cannot change is the speed of light. And that's California, Netherlands, that's the speed of light it takes to get from there to there. You have to pay that price. So maybe, but yeah, paying the speed of light tax. Yeah, you could, because each thread kind of has handles its own threading. I've never seen an app do that before. That'd probably be bad UI, but theoretically you could. Actually, you can't, because tabs can't share data between each other. It's a security model baked into the browser. You cannot get past that unless you hack it, which I don't think it's not possible. So message queuing, you probably have to like send it off there, send it to a server, have that server send it back to you, and then it doesn't even matter anymore either. The message channeling is the key feature there. Oh, can you? Yeah, you could. Yeah, theoretically. Yeah, I wouldn't do it, but you could. Yeah. It's like a JavaScript in general. Like, you can do this. Like, you can change the prototype of an object model, but like, don't do it. Like, you can, but do not. Yeah. Good and bad. Okay.
What's the mechanism with web workers for like synchronizing? If you start 5 chunks of this task and you want to collect them when they all finish.
Yes, good question. I can show you. Maybe it'd be helpful to look at the source code of this thing. Also, the question is, what happens? We have multiple threads going out. For example, this password cracker, and we want to stop the separate threads once one of the threads has found the password. So I can show you how they do that. And they do it very similar to me. Let's look at I think that's is it this one? Nope, I think it's in the index.html. Nope, I can't remember where they put it. Actually, I'll just show you my code because I know where that would do that. So for example, this thing here, we have our multiple workers on here. Once one of them hits a complete, what I would do is just terminate all the other workers. I would loop through and just, on the complete message being received from one of the workers, go through and just kill all the other ones until we're done.
The more usual thing I'm used to is you send them out to do work and then collect the work at the end.
Yes. Yep. So that'd be another example too. Like this password cracker is different because we don't need to wait for them all. We just need one of them to complete. But that'd be another one too. So you could totally do that too. So we just have some sort of thing that waits for all the workers to fire off. We have to wait for 8 complete messages to be returned, and then we can start executing some sort of code or something. Yep. The question was, yeah, how do I rephrase it?
Let them all complete and then just have a data collection pool.
Exactly, in the main thread. Yep. All right, cool. Any other questions? One more, yep.
Do they have methods built in to do that, or do you kind of have to reinvent the wheel and do it? I know in like
Yes. I have not, so the question was, are there methods for like collating data between workers? I have not seen any. All the examples I've seen and all the code I've done I've been basically having to like write custom switch cases. There might be a framework. I'm not aware of one. Maybe it's a good open source tool if anyone has any free time. Yeah, there probably has to be. I don't know. I haven't done a whole lot of work on that.
Creating a promise for each worker and then promise that all.
That's true. Yeah, map it or something. Yeah, I think that's probably true. Yep, that's actually great. That's a great solution. All right, cool, awesome. Well, everyone, thank you so much. This has been super fun. We took about 45 minutes. That's great. So you had about a couple minutes here before lunch. I'm gonna let's see here. I have additional resources, so I want to restate. I'm gonna be posting these slides on my my Twitter. I'll be posting these resources and yes, and the code. And if you have any questions about it, I'll be out today and tomorrow. If you like this talk too, I'm giving a talk tomorrow, I think at, 2:30 or something, later in the day on introduction to GraphQL, building that in JavaScript. Yes, that's a fun one too. That's a really fun talk too. So come on, if that's something that's interesting too. Otherwise, here's my socials. You want to take a picture of that. And yeah, thank you so much, everyone. I appreciate your time. All right, get out of here. There's stickers over here too. If you run out, let me know. I have more.